In this video, we're going to look at the quotient rule, which is written as if u of x and v of x are two functions, and f of x is equal to u of x over v of x, then f prime x is equal to v of x times u prime x minus u of x times v prime x all over v of x to be squared. So we look at this in its simplest terms with a question: f of x is equal to 2x minus 3 over x squared minus 4. F prime x is equal to. So like the product rule, differentiate both and just write your answers down. We have 2 and 2x. So it's the bottom, x squared minus 4, which is this v of x. It does make a difference here because of this minus sign in the middle. The order does matter, whereas in the product rule it didn't. So it's the bottom by the top differentiated minus the top by the bottom differentiated. And normally we'd put this 2 in front and this 2x in front when we're multiplying. And it's all over the bottom to be squared. So x squared minus 4 to be squared, which we never have to multiply out. So we're going to get 2x squared minus 8 minus 4x squared plus 6x all over x squared minus 4 to be squared. And tidying up the top line, we're going to get minus 2x squared plus 6x minus 8 over the bottom to be squared, which is x squared minus 4 to be squared. In these two questions, we're looking to evaluate the derivative of each of the following at x equals 0. You can see here we have a product rule and here we have a chain rule. So we could apply those rules first. Definitely in the second one we're going to do that, but in the first one I'd multiply out the bracket here: 2x squared minus 4x plus 5x minus 10, and just continuing with the top line, we're going to get 2x squared plus x minus 10. So the derivative of this is 4x plus 1. The derivative of the bottom is just 1. So following your rules of the quotient rule, we have the bottom, x plus 3, by the top differentiated, which is 4x plus 1, minus the top, which is 2x squared plus x minus 10, by the bottom differentiated, which is just 1, all over the bottom squared, which is x plus 3 to be squared. And obviously not x plus 4, at the bottom was x plus 3. Now we're asked to evaluate at x equal to 0. We could simplify this top line, or we could just put x equal to 0 in. So if x is equal to 0, we're just going to end up with the 3 by the 1, which is 3. And we're going to end up, these are zeros, so we're going to end up with this minus sign here by minus 10. So it's going to be plus 10 over, this is 0. So we just have 3 squared, which is 9. So it's going to be 13 over 9. So if we differentiate the top line here, we're going to get 7 by 3x squared plus 4x plus 2 to the power of 6. And then multiplying by the differentiated bracket, we're going to get 6x plus 4. So we could tidy this up. We could write 42x plus 28 times 3x squared plus 4x plus 2 to the power of 6. And the bottom differentiated is just going to give me a 1. So we have the bottom, g prime x is going to be equal to the bottom, x plus 9, by the top differentiated, 42x plus 28, and you can see why they'd have to let x equal 0 here, otherwise we'd be here all day, by 3x squared plus 4x plus 2 to the power of 6, and then minus the top, which is 3x squared plus 4x plus 2 to the power of 7, just times that 1, which won't affect it, all over the bottom squared, which is x plus 9 to be squared. So we let x equal 0 here. So we could tidy this up and multiply these brackets out, and we've two things multiplied. But if we're told that x is equal to 0, we just have this 9, this 28, and this 2 to the power of 6. And if we take away 2 to the power of 7 and type that into a calculator, it's going to give us 1600 even. And then at the bottom we just have 9 squared, which is 81. So that would be the answer. So when you see a big long list or line of algebraic expressions and x is equal to 0, just sub 0 in and you'll end up with the constants. So let's look at some more quotient rule questions. First of all, let's have a look at 3 questions where we can actually simplify them first. But let's do the quotient rule and then do the simplified version to check our answer. So you can see this first one here, y is equal to x to the power of 8 over x to the power of 2 would be y is equal to x to the power of 6. But if we use the quotient rule, this is going to become 8x to the power of 7. This one is going to become 2x. So dy dx in this case is equal to the bottom, which is x squared, by the top differentiated, which is 8x to the power of 7, minus the top, which is x to the power of 8, by the bottom differentiated, which is 2x. And that's all over the bottom, x squared to be squared. So we're going to get 8x to the power of 9 minus 2x to the power of 9 over x to the power of 4, which is going to give me 7x to the power of 9 over x to the power of 4, which is equal to 7x to the power of 5. Now, we could have started off with x, of course not 7, 6x here, 6. So we could have started off with x to the power of 6 if we simplified it. So dy dx is equal to 6x to the power of 5. So 8 take away 2 is obviously not 7. So don't try and go too quick. And you can see here difference of 2 squares on top. But if we differentiate the top, we're going to get 2x. And if we differentiate the bottom, we're going to get 1. So I'll leave out the dy dx, you know what we're doing here. So I'd always start with putting the bottom squared on the bottom. And then the bottom by the top differentiated minus the top by the bottom differentiated, which is just 1 in this case. So we're going to get 2x squared plus 6x minus x squared plus 9 with the signs on top, all over x plus 3 to be squared. So we're going to get x squared plus 6x plus 9 over, now if I multiply this out, I'm also going to get x squared plus 6x plus 9, which is equal to 1. So where does that come from initially? Well, on top we have the difference of 2 squares, so we have x plus 3 by x minus 3. On the bottom we have x plus 3. Dividing by x plus 3, we get y is equal to x minus 3. So dy dx is also equal to this 1. And lastly, this could be 3x to the power of 4 plus x, but if we do it the long way first, just so we can double check our answers, we're going to get 15x to the power of 4 plus 2x if we differentiate the top. We're going to get 1 if we differentiate the bottom. So we're going to have the bottom to be squared. We're going to have the bottom multiplied by the top differentiated minus the top by the bottom differentiated, which isn't going to change its value. So we're going to get 15x to the power of 5 plus 2x squared minus 3x to the power of 5 minus x squared all over x squared, which is going to give me, we have 15x to the power of 5 minus 3, so 12x to the power of 5 just plus 1x squared over x squared, which is going to give me 12x to the power of 3 plus 1. So let's have a look. If we simplify that top, we would have had 3x to the power of 4 plus x, which is going to give me dy dx to be 12x to the power of 3 plus 1. Same answer both times. So it's up to you within a question. If you can simplify it first, like we had up here as well, we multiplied this bracket out rather than applying the product rule. You're not going to multiply this out to the power of 7. So just look at the question, analyze what the easiest way of doing it is, and then follow that method. We look at another example here where we're given a value for x. So find the value of the derivative of f of x is equal to 3x plus 4 over x squared plus 2. So the top is going to give me a 6x. The bottom is going to give me a 2x. So we have the bottom to be squared, x squared plus 2 to be squared on the bottom. And we have the bottom, x squared plus 2, by the derivative of the top minus the top, which is 3x squared plus 4, by the derivative of the bottom, which is 2x. Now we could tidy it up again, but we're told x is equal to 1. So f, this is f prime x. there's no bonus points for tidying it up, so f prime 1 is what you're asked for, so you're going to get 1 plus 2 by 6 minus 3 plus 4 by 2 all over 1 plus 2 to be squared, which is equal to 3 by 6, 18, minus 7 by 2, 14, over 1 plus 2 to be squared, which is 9. So it's going to give me a value of 4 over 9. So one more example and you should probably be sick of quotient rule at that point. So again, we're given a value for x. X equal to 1, it could be x equal to 0. It could be x equal to 2, but not really much higher than that. So g prime x is equal to follow the same process. That's a 3 if we differentiate, and that's a 4 if we differentiate. So we have the bottom to be squared on the bottom, 4x plus 3 to be squared. We have the bottom 4x plus 3 by the derivative of the top, which is 3, minus the top 3x plus 4 by the derivative of the bottom, which is 4. So tidying this up, we get 12x plus 9. It's an easy one to tidy up, so tidy it up, and then we're going to have minus 12x minus 16 all over 4x plus 3 to be squared. So that's going to give me, the x's cancel, so we're going to get minus 7 over 4x plus 3 to be squared. So g prime 1 is equal to minus 7 over 4 plus 3, 7 to be squared, which is equal to minus 1 over 7, or minus 7 over 49. If it was 0, you could see it'd be minus 7 over 3 squared, which is 9, and so on. So that's the quotient rule. We're going to move on to trigonometric functions in calculus 5. So master product, quotient and chain before moving on.